Hello, Algebra 1, and welcome to your 2.5 notes for literal equations. So we are going to dive in. If you guys printed this out, great. If you haven't, just write it into your notes. Same thing. So literal equations, what are literal equations? So they are equations. Oops, brand new pen. Okay. Are equations with multiple variables. And often this is something that you kind of will see in science a lot. So when you're trying to get like a formula and you have one part of it, but you don't have the others and you're trying to isolate that one part, this is where it kind of comes into play. So what we're going to do is we are just going to look at first something that we've already talked about, something we know how to do, and then a literal equation that's very similar to the 2x minus 15 equals 13 type problem. So whenever we are solving an equation for a variable, for a specific variable, and in this case, we are solving the equations below for x, the first thing you want to undo is addition or subtraction. So remember, it's going in the opposite direction of PEMDAS. So the first thing you want to undo is the last thing you do in order of operations. So the first thing you undo is addition and subtraction. So let's just kind of write ourselves a reminder. So undo addition and subtraction first. So that means, and remember, if you guys need to draw the line down the equal sign to kind of separate both sides, you can totally do that. So the first thing we're going to undo to get x by itself is whatever's being added or subtracted on the same side. And so that minus 15 is subtracting. So to move it to the other side, we're going to add 15. Okay. So the 2x comes down, negative 15 plus 15 cancels, equals, now 13 and 15 are like terms, so we can combine them. 13 plus 15 is 28. Okay, so then we still need to solve for x, so we're still trying to get x all by itself. And so now we undo our multiplication or division. So this is being multiplied. 2 times x is being multiplied. So we would divide both sides by 2. And we get 2 divided by 2 is 1, 1x, which is what we want. 28 and 2, we can divide those. 28 divided by 2 is 14. And so I get my final answer of x is equal to 14. Now, it's pretty straightforward when there's numbers involved, but let's look at this equation here. It says ax minus b equals c. So it's really similar, except instead of 2, we have an a. Instead of negative 15, we have a minus b. So our goal is the same. Our goal for this problem over here is to solve the equation for x. So we still follow kind of the same order that we did over here. The first thing I did was I added 15 to both sides. Now I'm going to do the same thing here. And again, if you need to draw a line, great, do that. So what we can do first is we undo anything that's being added or subtracted. So this is a minus b. So to undo a negative b, I'm going to add b to both sides. And then what happens, ax comes down, negative b plus b cancels. Anything like a negative and a positive of itself is always 0. And then equals c plus b. So c plus b, those are not like terms. So what we want to do is we can't combine them. So we just write it as c plus b. Can't combine them, not the same variable, so we just leave it as is. Just like we did here, but this one was just a little bit nicer because 15 and 13 were like terms, so we could combine them. Okay, now again, our goal is to still get x by itself. X has that a being multiplied. Now what we did here to get rid of that 2 that was being multiplied is we divided both sides by 2. Now we're going to do the same exact thing, and we're going to divide both sides by a. Now, when I do that, I'm dividing C by A and I'm dividing B by A. Now, there's 2 different ways that you guys can write this. I'm going to show you one of the ways. So, A divided by A is 1, and so we're left with just X by itself. So that would be C over A plus B over A. Those can combine, nothing we can do there, so we leave it as is, and that is my final answer. If you wrote C plus B all divided by A, that would be the same too, and that would be completely fine. Okay, so let's move on to some more literal examples. Literal equation examples, yeah. Okay, so first thing you always want to do is figure out what variable it's asking you to solve for. So it's asking us here to solve for W, so that means we want to get W by itself. So I just look at what's happening. Is there any addition or subtraction on this side of the equal sign? And again, if you need to write that line, write that line. So is there any addition or subtraction happening on this side? And there isn't, so we move on. Is there anything being multiplied or divided to W? And there is. It's L times W. So to undo multiplication, we divide both sides by L. That's just a cursive L, because sometimes my L's look like ones. So now we have A divided by L equals L divided by L, which is 1 W. So did we get W by itself? Yes, there's nothing else on this side of the equation. So I'm done. I have W is equal to A divided by L. So you have like this formula up here, area equals length times width. We know that formula. That's the area of a rectangle. And so if I was given the area of a rectangle and the length of a rectangle, I could use this format of the equation to solve for my width. So if I was giving area and length, I could solve for width. Okay, so I want you guys to look at number 2. Distance equals rate times time. That's one of your science formulas. And it says solve for t. So what I want you guys to do, I want you guys to try 2 on your own. So pause me here and try this problem on your own. First thing I did is just identify what variable I'm trying to solve for, and then I'm going to solve for that variable. So this one was really similar to number 1. We had to get t by itself. The only thing that was happening was r was being multiplied. So to undo that multiplication, I divided both sides by r. And my final answer is t equals distance over rate, or d over r. And that is my final answer. Okay, let's look at number 3. So d equals m over v. And it says solve for m. So first thing, I always just like to figure out what variable am I trying to get all by itself. And then I look, okay, so is there anything that's being added or subtracted on that side of the equal sign? And there isn't. There's no addition or subtraction on this side of the equal sign. So then to get m by itself, m is being divided by v. So to get m by itself, we have to undo that division. So the opposite of dividing, oops, I'm throwing pens. The opposite of dividing is multiplying. So I'm going to multiply v to both sides. And so v times d, or d times v, doesn't matter. And now is m by itself? Yes, it is. And so that would be my final answer. M is equal to d times v. You don't need to put that like dot in between. When it's the letters right next to each other, we can always assume that multiplication is happening in between. Okay, so I want you guys to look at number 4. I want you guys to try 4 on your own and then go from there. So see if you guys can try 4 on your own and then come back and check your work. First thing I do is identify my variable. I'm looking to solve for r. Now, there are 2 things here that are multiplying by r, 2 and pi. To undo multiplication, just like I did in 1 and 2, I divide. I can still do this in one step like I've been doing all the others. I can just divide both sides by 2 pi. And so c over 2 pi, nothing can simplify there. And then 2 pi over 2 pi is 1. Anything divided by itself is 1. And so r is left all by itself. And now we got it isolated. So r is equal to c over 2 pi, which is the circumference of a circle. Okay, let's look at number 5. So a equals 1/2 base times height, area of a triangle, and we are asked to solve for h. So we have that fraction. I know sometimes that fraction can throw you guys off. So instead of writing it like this, we can assume it's the same as me writing it as this, b times h divided by 2. 1/2, it's just saying the 2 is in the denominator, 1 is in the numerator, so 1 is on top, but 1, we don't need the 1. 1 times b times h, it's just b times h. So we are trying to get h by itself. So we don't have anything that's being added or subtracted. And what I notice is I have this denominator. When I have an entire expression over something, I always actually want to get rid of that first. So what I'm going to do is I'm going to undo that division by multiplying both sides by 2. And so I have 2a equals b times h. Now, I still haven't achieved my goal here. Remember, my goal is to get h by itself. So I want you to continue on and solve for h, get that all by itself, finish this last step, and then come back to check your work. All you had to do is divide both sides by b. b divided by b is 1, and so I'm left with h all by itself is equal to 2a divided by b. And that is my final answer. Okay, so let's look at 6, almost through. So for 6, it says solve for c. Now remember what I said on 5. Whenever we have an entire expression like b plus c over a denominator like that, what we want to do is we want to get rid of the denominator first. I know that goes against our undo addition and subtraction and undo multiplication and division. But whenever you have that entire denominator, over an entire expression that's adding or subtracting or multiplying and dividing, you want to get rid of that first. You want to always undo this division first. So that's what I'm going to do. I'm going to multiply both sides by d. The d and the d will cancel. And I'm left with a times d equals b plus c. Okay, again, I'm still trying to get c all by itself. So now I can look to see, do I have any addition or subtraction that I want to undo? And we have a b here. So it's a positive b. Whenever there isn't a sign attached to it, we can always assume it's positive. So to undo an addition, I'm going to subtract b from both sides. Now, AD and B are not like terms. So AD and B cannot be combined. So we would just write this as AD minus B equals C. And did I get C by itself? I did. It's a positive C. That's what I want. So C equals AD minus B is my final answer. Okay, last two. Now, these last two are probably the most important that we are going to do because we do this all the time in algebra. You do this all the time in geometry and honors algebra 2 and all of your classes. For math, you are going to do this. So these are really, really important. So 7 says solve for y. So that means we're trying to get y by itself. I'm going to go through this. I'm going to put my line down just again to keep us organized. So first thing I want to do is I want to undo anything that's being added or subtracted. I don't have an entire like dividing by something, so I don't have to worry about that. But I want to undo anything that's being added or subtracted on this side. So we have a 2x. It's not multiplying. It's a positive 2x. So to undo that, I'm going to subtract 2x from both sides. 2x minus 2x is 0, so that cancels. I bring down my negative 8y equals 16 minus 2x. Those cannot be combined. Those are not like terms. So I write it as negative 2x plus 16. Notice how I wrote the variable part first and then the number last, just like we do when it's in standard form. Okay, I still need to get my y by itself. So to get the y by itself, that negative 8 is right next to it. So when it's right next to it, it means that it's multiplying. So to undo multiplication, I would divide. Divide everything through, just like I did on this first example that we did up above. I divided everything through by 8. Here, I'm dividing everything through by negative 8. Now, what's really important with these, like when you're dividing, unlike up above, I couldn't reduce C over A and I couldn't reduce B over A. So with these, I do want you to make sure to reduce the fractions if possible. And so what I mean by that, so negative 8 divided by 8 is 1. So y equals. But negative 2 divided by negative 8, well, first a negative and a negative make a positive. So we can do that. And 2 and 8, they both have a common factor. They both have a common factor of 2. 2 can divide evenly into both of those. So 2 divided by 2 is 1. And 8 divided by 2 is 4. So 1/4 x. And then 16 divided by negative 8 is negative 2. So that's what I mean by make sure to reduce the fractions if possible. And so this would be my final answer. And that's it. So that is really one of your like most important things that you guys are going to be doing throughout this year in this class. So it's super important that you understand how to isolate the y when you have this type of equation. So let's move on to 8. It's the same exact type of problem. So what I want you guys to do, I want you guys to just start this problem on your own. So you're getting y by itself. So what's your first step? Okay, so my first step that I did was I subtracted the 9x from both sides. 9x minus 9x cancels. I bring my negative 3y down. Make sure you bring that negative sign down. Equals negative 9x plus 12. Make sure you're putting it in variable first, constant second. Okay, so from here, do your next step. So from here, continue on and do the next step. So your next step should have been dividing everything through by negative 3. So negative 3 divided by negative 3 gets me y, and now comes our reducing. So negative 9 divided by negative 3, that actually gets me a whole number. Negative 9 divided by negative 3 gets me positive 3x, and 12 divided by negative 3 gets me negative 4. And so that is my final reduced answer. And that is it for the notes today. So we will do more practice with this in class. So make sure you guys are bringing your questions to class so we can review these and go over any areas of issue. Have a great day, guys, and I will see you soon. Bye, guys.